All right, so as I said earlier, this week we're going to kind of get away from the graphing. Okay, we're not really going to use any sine, cosine graphing the waves or any of that stuff. We're going to go back to something we did a couple weeks ago, which is solving triangles, okay, finding the sides and the angles. But when we did this a couple weeks ago, the week before we did graphing, every problem always had a 90-degree angle. We're going to look at problems this week that don't have 90. Okay? And those are called oblique triangles, okay, without a 90. Anybody remember there was a theorem when you have a right triangle you can use to find the sides? Yeah, when you have a 90-degree angle, you can use Pythagorean theorem. When you don't have a 90-degree angle, you can't. Okay, so Pythagorean theorem isn't going to be something we can use this week. Also, does anyone remember the name of the side across from the 90? What do we call that? Yep.
Hypotenuse.
Hypotenuse, good. Well, if you don't have a 90, then you don't have a hypotenuse either. So there is no hypotenuse. So when we talked about the different trig functions like opposite over hypotenuse, adjacent over hypotenuse, none of that applies. There is no hypotenuse this week. So we can't use that SOHCAHTOA. Can't use that either. So we're going to look at something a little bit different to try to solve these. We can still use the fact that all the angles add up to a certain number. That doesn't change no matter what kind of triangle you have. Anybody remember what that is? What are all the angles, Jeff?
180.
Good, 180. So that's still true. Okay. But when you don't have a 90-degree angle, that's called an oblique triangle. And there's really two types you can have. You can have what's called an acute triangle. Think of one example would be like an equilateral. All the angles are less than 90. Or you can have an obtuse triangle where one angle is more than 90. Now, how come I said one angle? Why couldn't you have two angles more than 90? Yep.
It wouldn't be a closed shape.
It wouldn't be what?
A closed shape?
Yeah, it wouldn't be a closed shape. I think I said a cool shape at first. Yeah, it wouldn't be closed because it wouldn't be adding up to 180 if you had two angles that are more than 90. So you can only have one angle more than 90. And again, just to be clear up front, none of my sketches are going to be to scale. All right, so when we sketch things, it's more important what's across from what, not that we take on a protractor and draw this thing perfect. Okay. So here's going to be our diagram that we use for solving right triangles. Okay, and I'm pretty much going to draw the same sketch every time. Okay. Notice that for the sides, I've done the same thing we always do. We use English alphabet lowercase letters, A, B, and C. For this kind of problem, it doesn't make sense to say C is the longest side. It might be, it might not be. Okay, there's no 90 anymore. But notice where I put the Greek letters in relationship to the sides. Let's start with the one in the lower right. Anybody remember the name of that one? And it always has to go across from A. James?
Alpha.
Yep, that is alpha. However you draw your triangle, always put alpha across from A. How about this Greek letter? It's always across from B, and it begins with the same letter when you pronounce it. Yep.
Beta.
Beta. So this is the Greek letter beta. And now, this one is one we haven't used. Because before, that was always a 90. So we just drew in the symbol for 90 degrees, and that was it. Well, now, this symbol, which looks like that, is gamma. So that's the Greek letter gamma. And gamma will always be drawn across from C. A across from alpha, B across from beta, C across from gamma. Now, if you remember, when you're solving a triangle, thank you, there's always 6 things you have to find. You didn't want to go down. You didn't want to go down. Okay. There's always 6 things you have to find. 3 sides, 3 angles. In order to solve it, I have to give you 3 of those out of the 6. Okay? And depending on what 3 pieces of information I give you is going to control how you solve it. There's two formulas we're going to learn this week. One of them is called law of sines. The other one is called law of cosines. Today we're going to look at law of sines. Law of sines is used to solve 3 different kinds of problems. It's used to solve problems where they give you 2 angles and a side. And I've actually broken that down into 2 different things. Both of these are 2 angles and a side. Angle, side, angle is 2 angles and a side. Side, angle, angle is 2 angles and a side. So you might go, well, what's the difference? It's both 2 angles and a side. The difference is where the side is. Is the side that they gave you between the 2 angles, or is it not between them? It makes a little bit of a difference in how you solve it. On the left is an example of angle, side, angle. The side that they gave you is between the 2 angles. It connects them. The one on the right, they gave you 2 angles, and the side they gave you this time is not the one that connects them. The bottom one is the one that connects them, and you don't have that one. So we call that angle, angle, side. You can write it this way too. This means the same thing. SAA, AAS, it doesn't matter. Okay, so that's 2 cases that we're going to use for law of sines. We're going to do one of each of those today, and we're going to do one of these. This one is a little different. This time it's 2 sides and an angle. And it's very important that the angle that they give you is not between the 2 sides. It cannot be where the sides meet. So in other words, in this problem, they cannot give you the one I just circled in red. That would be not good for what we're doing today. They have to give you an angle that is one of the 2 where the sides do not come together. So this one is fine, or this one would be fine. In both cases, it would be an angle that's not where the sides meet, not between. Okay, and I told you you can change the order. If you write this backwards, it means the same thing. This one we'll leave in that order. It's not nice to write it the other way. We'll just leave it as SSA. So to solve any of those 3 types of problems, we're going to use law of sines. So you're not going to have to think about it too much today, but on the test, it's going to be a mixture of law of sines problems and law of cosines problems. So the first thing is going to be to figure out which formula do I use, and you can't switch them. You have to use the right formula on a certain type of problem. So if I was making a reference sheet, I would probably write down like law of sines, and I would put these 3 under it. So then I know, okay, these are the 3 I use law of sines for. We're going to do law of sines today and tomorrow. Law of cosines will be on Wednesday. And then review on Thursday for those that weren't here.
Mr. Hager?
Yeah.
Can you go back up to the side angle triangle?
Side angle, yeah.
Just got a copy.
And when they give you a problem, this is fine. They could definitely just draw a picture for you, and that makes it a little easier. If they give you information that's just written out, you want to make a picture first. Okay? It's really the only way to visualize, what do I have? Do I have the side between the angles? It's kind of hard to see all that if you don't have a picture. So you might get a problem like this. we're not doing this one yet, but I would make a sketch, okay, right away. All right, any questions on that? All right, so let's take a look at this. So I'm going to try to explain what the formula is for the law of sines. And then once we know what it is, I will show you how to use it. Okay, so to explain the law of sines, I've just drawn a triangle. I didn't label all the sides because I'm not going to use all the sides. I only labeled what I'm going to need. So I labeled A, put that across from alpha, B, and I put that across from beta. And the other thing I did was I drew a line perfectly straight up and down, perpendicular to the base. So I separated that into two triangles, not necessarily splitting it right in the middle, just two separate triangles that are not the same. Right, and what I'm going to do is I'm going to block half of this picture out, and I'm just going to focus on the left side for now. And then I'll focus on the right side after. Right, so let's take this and block this off. And let's call this side H for height, not for hypotenuse, so it can be a little confusing, but H for height. That's also called the altitude of the triangle, but if I call it A, that's also going to be confusing because I already used A as another letter. So let's just stick with H. All right. And what I want to do is write a formula to find H. Now for this, we don't need anything fancy. This goes back to what we did a couple weeks ago because the way I drew this line in, it's a perpendicular. It created a right angle. So all the stuff that we learned about right triangles before, that's going to apply to this problem because of that extra line that I added. All right, so focus on these three things in green. What I want to do first is label the two sides that I have an H and a B on. And the labels I want to use are either opposite, adjacent, or hypotenuse. Anybody remember the name of the side that's labeled H? From the perspective of alpha. Is it opposite alpha, adjacent alpha, or is it the hypotenuse? Done? Opposite. That's opposite. That's opposite. And how about the side that's labeled B? What side is that? Yeah, yes? That's my hypotenuse. Okay, so now I know the names of the two sides, opposite and hypotenuse. Which trig function, sine, cosine, or tangent, involves the opposite side and the hypotenuse?
Sine.
Yep, sine. So sine of alpha equals, and can you tell me what I put on the right-hand side?
H over B.
Perfect. H over B. Sine equals opposite over hypotenuse. I don't have any numbers there. I don't need numbers there. Okay, but it's fine. Now, let's get H by itself. All right, so Raymond, how would I get the H by itself, basically? How would I get rid of the divide by B?
Would you multiply?
Yeah, and what would you multiply both sides by?
B.
B. Let's do times B. And times B. And now we have B sine alpha equals H. Right, so we have a formula to find the height. We'd have to know B and we'd have to know what alpha is, and we'd type it in on the calculator. And I'm just going to call that box 1. So when I refer back to it later, I can just say, look at box 1. Any questions on that? Yeah.
How do you know when to use sine and then when you multiply?
So because of the two sides that I circled and their names were opposite and hypotenuse, that tells you that it has to be sine, because cosine would have been if I had adjacent and hypotenuse, which I don't, and tangent would have been opposite and adjacent, which I don't have. So based on the two sides that I circled for you, you have to use sine because of their names.
Any chance could you write it down real quick so I can just copy?
So sine, remember that's the opposite over hypotenuse. Cosine, which we're not using. And tangent, which we're not using. Jess, what's up?
So do you always just start at alpha, or would you like tell us when to start?
You'll see when we do a problem.
Okay.
So this is more kind of explaining what the formula is, and then the next step is once we have the formula, how do you use it?
Okay.
So then we're going to go through that. Yeah.
When solving it, how do the trig functions fit into order of operations?
How do trig functions fit into order of operations?
Yeah.
So like if you had something like this in a problem, well, order of operations is just arithmetic. So order of operations here, trig functions you always do first.
Okay.
So in terms of PEMDAS, I guess you know how they say P is parentheses, but
Yeah,
parentheses are really a grouping symbol.
Yeah.
You can kind of think of this as your grouping symbol, and you always do that first, then times 2, then lastly plus 6.
Okay.
Yeah. All right, so any questions on that formula in box 1? All right, so now let's cover the left side, and let's do the same thing again. Okay, I'm going to put the H right there again. It's the same H we had before. And I again want to write a formula for H, except this time I want to use the information on the side that I'm circling here. All right, so let's start by writing down the names. Colby, what's the name of side H from the perspective of beta? Yep, that's opposite again. And Lacey, what's the name of side A? It's hypotenuse, yep, because it's across from the 90. So the two sides involved in this one are opposite and hypotenuse. And I want to think of, again, which trig function would relate those two. So what's the trig function that has opposite and hypotenuse in it? Yeah.
Sine.
Sine, again. So this time, the sine of my angle equals, and could you tell me, Jess, what would be on the other side?
H. Yeah, H over A.
H over A. Okay. And I want to do the same thing again. I want a formula for H. Right, so Jacob, how would I get H by itself there?
Multiply A on both sides.
Yep, I'm going to multiply both sides by A times A. And now we've got a formula for H. Another formula for H. Okay, we already had one. A sine beta. And let's call that box 2. So box 1 is a formula that will calculate the height of this triangle. Box 2 is a formula that will calculate the height of this triangle. So what does that mean about box 1 and box 2? If you compare them to each other. Yeah? They're the same. You would get the same result, right? If you had numbers and you could do this out, it would come out the same. It's two different ways of finding the same height. So Vivian just said box 1 equals box 2. Let's write that down. So B sine alpha equals A sine beta. Now what I'd like to do is get certain things on the same side. Okay, I'd like to put the A over with the alpha, and I'd like to put the B over with the beta. How would I move the b over with the beta? What would I have to do to each side? Yeah, yes?
Subtract.
So what operation are we doing between the b and the side?
Divide.
We have to divide. Let's divide by b. Divide by b. And now at the same time, how would I put the a over with the alpha? Yep. Divide by a. And divide by a. So I'm just dividing by two things at the same time. When you divide by b, that's gone. When you divide by a, that's gone. And what we have there is basically the law of sines. It's the first two parts. Okay, there's one more part in it, but I think you'll be able to figure that out based on the pattern. So let's write this down. So, law of sines says that the sine of alpha divided by a is equal to the sine of beta divided by b, which is equal, and there's one more fraction. Anybody have a guess based on the pattern? What the last fraction is? Yep.
Sine of gamma over c.
Sine of gamma over c, yes. So that is the law of sines. Okay, so I consider that basically to have three parts. Whenever we're solving a problem, we're only going to use two parts at a time. Which two parts? Well, depends on what we're solving and what we were given. We might use the first two parts, we might use the last two, or we might use the first one and set it equal to the last one. Okay, but they're all equal to each other, all three of those fractions. Now, we could easily prove this last fraction just as easy as I proved the first two. I'm just not going to go through basically the same proof again. All you have to do is draw, instead of drawing the height to that side, draw it to a different side. And we could do it. Okay, but that's the law of sines. So, when we're solving the kinds of problems we're going to see this week, one thing we're going to do that's the same, we're going to make a sketch. We did that before. We're going to make our table. The only thing that's going to be different in the table is most of the time, you're not going to see a 90. In fact, I think pretty much every problem this week, you won't have a 90. If, for some reason, I give you a problem that has a 90 in it, you can use what I'm teaching you right now to solve it, or you can go back to Pythagorean theorem in the way we learned 2 weeks ago. But don't expect there to be 90-degree angles like most of the time. You mentioned that idea earlier. Remember that when you add up all your angles, they still have to add to 180. Jacob, can you just put your mask up? Thank you. And I think that was everything here. I wanted to show you. So you can see when we're solving problems, we're either going to use the first and the second fraction, the second and the third, or the first and the third. The point is you're going to end up using two fractions every time you solve it. In the fractions, we have 4 spots. You have a numerator and a denominator in each fraction. So that gives you 4 things to plug in. In general, you're going to have numbers in 4 of the spots and a variable, and numbers in 3 of the spots and a variable in the third. So something like this. Again, ours is going to have the word sine in it, but that's basically going to be the setup. Does anybody remember the technique you used to solve this? This is called a proportion. Yeah? Very good. You cross multiply. So in this case, 4 times x equals 8 times 2. And then you go from there. All right. And that's the technique we're going to use in every problem we do today. Okay, cross multiply. Our numbers probably aren't going to be as nice as these because we're going to have signs in there. We're not going to worry about rounding anything off with a calculator until we're at the last step. All right, so let's try. I think I have maybe three examples to go through. So we obviously know this is going to be a law of sines problem because that's what we're learning. Okay, we haven't learned law of cosines yet, so that's not an option. But if this was on the test, your first step would be to figure out, is this law of sines? So let's go through how we do that. How can we make this problem easier to visualize and to see what's across from what's next to what's going on? Yep. Yeah, let's make a sketch. So off to the side. Draw a triangle, which is again not to scale. And I'm going to put A across from alpha. That's how I chose to do it. I'm going to put B across from beta. Let's put B across from beta. And I can fill beta in because I know that's 60. So that's beta. And I can put C across from gamma, but I can't fill in the C and I can't fill in the gamma because I'm missing both. Okay, so there's our triangle. Now, out of the three types that I gave you at the beginning, like the angle, angle, side, angle, anyone think they can tell me which type this one is? Yeah.
It would be angle, side, angle.
So for it to be angle, side, angle, that means they gave us two angles and a side, and the side that they gave us connects the two angles. It's between the two A's. Did they give me the side that connects the two angles? What is the side that connects the two angles?
C.
C. So it's not angle, side, angle, but yeah.
Is it side angle angle?
Yeah, it's a side angle angle. Or you could write angle, angle, side. Same thing. You know two angles and a side, but the side that you know is not the one that's between the angles. All right, so now that we know it's this type, you would look in your chart on your reference sheet and say, oh, okay, side angle, angle, that's law of sines. All right, so now let's make a table. And I put a box around everything we need to find. All right, so does anybody see something you could find first? And it really doesn't involve the law of sines in this case. Don't worry, it will soon, but not yet. Yeah.
Figure out the third angle.
Yeah, we know the third angle. What can you tell me what the third angle would be?
80.
Yeah, it would have to be 80. Because the first two add up to 100. That adds up to 80, makes it 180. Just like last week, you can get partial credit for every one of these you get right. So if this was a problem on a test, that would be worth like 1 point out of 3 points for this problem. Now, what did I say last week about using like something like gamma to now calculate other things? Done?
You don't want to do that because if you messed up on one part, you're going to mess up on all of them. If you use the original numbers that you were given, then you can mess up on one part and still get the other answers right.
Right, and last week that was exactly what happened. That was always true last week. You could just stick with what was given, and that would help you find everything. This week, you can't do that. You're going to have to use things that you calculate sometimes to find other things. Not always, but sometimes. So, What that means is if you make a mistake in this problem, finding gamma, then you're going to get C wrong, automatic. You could still get B right, because the only thing we're going to use to find B is beta, and that was given, so that's separate. But if you get gamma wrong, we're going to get C wrong as well. There's no way to avoid using gamma. So when you have a really simple calculation where with nice numbers, just double check that they all add up to 180. Okay. All right, so that's gamma. Now let's find B. At this point, you have an option. You could do B or you could do C. It's going to be almost the same exact steps repeated, right? So, anytime we want to set up a law of signs problem, I always go like this. Because you know you're going to set up two fractions. You always want to pick a row that has everything in it. Which row has everything in it here? Row A, B, or C? Yep. Yeah, row A. So we're going to use row A, and I'm going to plug in these two numbers, the 40 and the 4, right into this formula right there. So it's going to be sine of 40 divided by 4. Let's start with that. Sine of 40 divided by 4. Now, we're finding B. So I'm going to go back to the formula again. I'm going to look at the part that has B, and I'm going to use that. I'm not using this last part right now. I will later, but not yet. So fill in sine beta divided by B. I can fill in everything you can. Beta is 60, and B we don't know. So that's what we're solving for. Okay, so look at your proportion. Make sure that you have numbers in 3 of the spots, and there should only be 1 spot with a letter. All right, so bottom, what did we say earlier is the technique we use to solve a proportion?
Cross multiply.
Yep, we're going to cross multiply. I'm not worried about a calculator at this point. I'm going to need it, but not yet. So we're going to have 4 sine 60 equals B sine 40. And that's B times the sine of 40. All right, and now we want to get B by itself. So Cassidy, what would I have to do on both sides to get B by itself?
Divide by B.
So if we divide by B, what would happen is this. We'd cancel the B out from the right, and then it would be in the bottom on the left. So dividing by B doesn't get B by itself, but we do want to divide. I do like that idea.
Sine 40.
We want to divide by the sine of 40. It's just like having like B times 12. Right? You want to divide by the number you're multiplying by. In this case, it's sine 40. Again, I don't care what the sine of 40 is. Just divide both sides. That's gone. That's gone. Now I care about what that is. I have to type it in. That's going to be my formula for B. All right. What before I even type anything in, what should I check on my calculator? Yep.
You have to put it in degrees.
I should be in degrees. Every problem we do this week is degrees. Okay. So always make sure you are in degrees. Also, every answer we do this week should come out positive, because you're finding how long a side is and how big an angle is. You don't get negative numbers when you do that. Okay, so let's type in 4 sine 60. If your calculator puts in the parenthesis, it's important that you close it. If you don't, it'll come out wrong. Divided by sine 40. So that is exactly how you would type it in on one of my calculators. If you want to use your own, that's fine. We might just have to check and make sure that you're getting the same answer. Okay, 5.389. Okay, if you're getting 5.389, then you typed it in perfect. If not, something's wrong. And that's generally how many decimals we'll go to. Okay. I rounded it to a 9 because the next digit was a 1, so that rounds down. If that was a 5 instead of a 1, I would have rounded that number up to 5.390. Okay. But it rounds down, 5.389. Okay. Any questions on how we solved for B? All right, now, could I use Pythagorean theorem to find C? Well, I could. I mean, I technically do anything I want, but yeah.
No, because you don't know if B is correct.
Okay, so
Like, you don't want to use something that you found.
okay, so if we can avoid it, we don't want to use things that we found to find other things. Again, I will tell you, you're not always going to be able to avoid that. But there is another reason why I would not recommend Pythagorean theorem here. No?
That leaves the opposite, and therefore, yeah, only the best option.
So that still doesn't really answer why I wouldn't use Pythagorean theorem. Yeah?
Because B came up to a decimal and gamma is a whole number, so it's gonna come out nicer and more accurate. And also it took less steps to get B, or I mean more steps to get B, so you were more likely to mess up on B.
Well, if you use Pythagorean theorem here, it's like using a toothbrush to cut a 2x4. It's just not the right thing to do. It's not going to work at all. It'll work as well as cutting a 2x4 with a toothbrush, I'll tell you that. Yep.
No hypotenuse.
There's no hypotenuse. This problem isn't a right triangle. Pythagorean theorem doesn't even exist for this problem. Okay, you can't use it unless this is a 90 and it's not. So it'll give you just a totally wrong answer. You can do it, but it won't work. Now, the other reasons that some of you said, like it's a decimal and stuff like that, yeah, we don't want to use decimals if we can avoid it, which is always good. So that would bring me to my next question, which I was then going to ask. I said earlier, you always want to pick a row that's full. Well, now you have 2 rows that are full. So technically, we could use either one of them. But a few of you already commented, try not to use the row with the decimal. Okay, so I'm going to stick with using this row again, okay, to find C. So let's write that down. It's going to start off exactly the same. Sine 40 over 4, okay, just like we had before. And what's going to go on the other side of that proportion to find C? Pete?
Sine 80 over C.
Yes, sine 80 over C. So I told you the steps were going to be pretty similar, and they pretty much are. Okay, we're going to cross multiply. And what I usually do is, I cross multiply, but I kind of do that part in my head. So if you want to show out the cross multiplying like we did in the first problem every time, that's fine. But when I look at it, I say, okay, the answer is going to be 4 times sine 80, and then I'm going to have to divide by sine 40. So 4 sine 80 divided by sine 40. It's exactly the same as the cross multiplying we did before. I just skipped the step in the middle. The reason you have to divide by the sine 40 is because you would have C times sine 40 after this step. you don't want to have c times sine 40. So how do you get rid of timesing something? You divide it. All right, and that's how we find c. Should c come out to be the smallest side, the biggest side, or in the middle? What do you think? Yeah?
The biggest side.
Yep, it will be the biggest. Okay. Before I always told you make sure your biggest side goes with the biggest angle. That'll still be true. And the smallest side should be with the smallest angle. So I know this should come out bigger than 5.389. Right. What does it come out exactly? Let's see. So on your calculator, if you can bring up the last thing you typed in, that speeds things up a lot because you end up typing the same thing over and over. So usually all you have to do is change one number, and then you can be solving for something else. If you can't, that's fine. Just type it all in again. Let's see, 6.128. That 8 would stay rounded to an 8. It would not round up to a 9. Right? 6.128. There'll be a little bit of flexibility with the rounding on the test. I'll accept it, like if you had like 6.1, 5 or 6.14, I would probably accept that because it's pretty close, but it should be 6.128. So don't touch the calculator until you're at the last step. Don't use it in the middle of the problem. Not for these type. All right. Any questions on that? So that's the side angle type. Let's look at this thing. All right, so this time they've already drawn the diagram for us. Okay, first thing I want to do is identify what type it is and see if that falls under law of sines. Okay, what type of triangle is this one? And by type, I'm asking you to tell me 3 letters. A's and S's. Yep.
Angle, side angle.
This is angle side angle. You might say, well, what's the difference between this one and the last one? The difference is the side. This time the side is between the 2 angles. It's the one that connects them. So remember, the whole key to law of sines is when you look at your table, you have a full row. And when we started last time, row A was the full row, right off the bat. You had a full row. Do we have a row that is full in this table? Meaning it has both things. Do you think, Jess?
No.
No. Okay, let me ask the question a little differently. Could we make a row that has everything in it? If we can, then we can still do law of sines. But somehow we need to have a row with everything in it. Either given or something we can find quickly, easily. Yep?
Yes, we can make gamma.
Okay, so we can find gamma. Bless you. Can you tell me what gamma would be? So what do these 2 add up to? Those 2 add up to 85. So what do you get if you take 180 and subtract 85 from it? Just minus 80 from it and then minus 5 more. That's how I would think about it. 95. Good job. 95. Now we have a row that is full. Now, you're going to use the full row in every law of sines problem to help you figure out everything you don't know. So what does that mean if we got 95 wrong in this case? What's going to happen? Yeah?
Everything else will be wrong.
Everything's wrong. It's not like the last problem where you could still salvage part of it and get some points. In this one, if you get this 95 wrong, it's going to mess up the A and the B. Because this is the most important row for figuring everything out. And now from here, it's just like the last problem. So let's do B first. Okay, you have a choice. You could do A or you could do B. They're independent, it doesn't matter. So let's find B. Let's see. All right, so Katrina, could you tell me how I could plug in, let's plug in this bottom row into my proportion on the left. So what would go in the top?
The top would be, this is the thing where we multiply, right?
For now, we're going to multiply in a minute to solve it, but for now, we just need to write something here and then something here.
That would be 4 sin 95.
So just sine 95. So that would be in the top.
Over.
And what would go in the bottom?
Oh, 4.
4. So sine of the angle in the top divided by the length in the bottom. And now we're finding B. So sine 40 over B. All right. Now, anyone think they can tell me what you get for B? You know, not decimal, just this times this divided by that. Yep.
4 times sine 40 over sine 95.
Perfect. And now we'll type that in and see what we get. And 4 sine 40 divided by sine 95. Again, you'll notice what you type in looks very similar every time. Just changing numbers. 4 sine 40 divided by sine 95. That comes out to 2.58. Now you need to round that up. That's 2.581 because that next digit's a 9. Right? 2.581. And that is B. All right. So now we're down to the last side. We've got 2 out of 3 of the sides. Could I use Pythagorean theorem to find A? Ava?
No,
No, why not?
because it doesn't have a right angle.
Yeah, it doesn't have a right angle. Right, this angle is close to a right angle. It's 95. And if you use Pythagorean theorem, you'll get a number that's close to the right answer. And I'll mark that on the test as close to almost being right. But that still means it's wrong. So don't use Pythagorean theorem, okay? You can't. It doesn't work. So we're going to find A the same way we found B. But we have a choice. We have 2 full rows. You can't make the argument and say, well, use the row where you didn't calculate anything. Well, no, we calculated something in both of them. So that's not a good reason to pick one over the other. But I still think there's another good reason to pick a certain row over another row. Yeah, Ava?
You should pick gamma because you don't want to use the decimal.
Yeah, at least if we use this bottom row, this wasn't given, but at least we know it's an exact answer. It's not rounded off, it's not a decimal, it's easier to work with. So we're going to use the bottom row again. Yep.
Also, because it was a lot less steps to get that one, so you're probably less likely to have made a mistake.
Yeah, this one was just a quick 180 minus 85. This one had a lot more steps in it, so hopefully we did a better job with this one. If we got something wrong, hopefully it wasn't the 95. All right, let's set that up to find C. I'm sorry, no, find A. All right, so major proportion. It's going to start off the same way, sine 95 over 4 equals sine 45 over A. All right, now before I solve it, if I scroll back up and look at my table, I can see that alpha and beta are pretty close. In fact, if alpha and beta were the same, that would already be done in this problem. Because if you have 2 angles that are the same, then you have 2 sides that are the same. But they're a little bit different. Alpha is a little bit bigger, so A is going to be a little bit bigger than 2.581. Okay. But keep that in mind, if you ever have a problem where two angles are the same, you're going to be able to finish that a lot quicker because it's isosceles. You only have to do this process once instead of twice. All right, so let's put down what A equals. Anyone think they can tell me what A is going to equal? And then we'll type it in after. Yep, Andrew.
4 sine 45 degrees divided by sine 95 degrees.
Right, 4 sine 45 over sine 95. All right, and let's see what we got. So 4 sine 45 divided by sine 95. Oops. I hit graph for something else. Sorry. That is 2.839. Okay. And as I said, it came out a little bit bigger than B. Any question on that side? So both of these types are pretty similar. You're solving for a side 2 times in a row. The only difference with this type is if you make a mistake finding this angle, it messes up the whole problem. If you make a mistake in the last problem, you could still get partial credit. Okay. So let's look at the last type, which is this one. And I'm going to write this in a table down below in a minute. So if you don't want to write, if you want to make the table now, you can. You should put A, B, C on one side, and then alpha, beta, gamma on the other. Okay, this one is a little different. What type of triangle is this one? And I don't mean oblique or obtuse. I mean with the A's and S's.
Side angle.
Good, side angle, and I like the order you put that in. We'll just leave it in that order to be polite. So side angle. So this time you're being given 2 sides first. So side angle is what we're basically going to finish with today, and we're going to be spending tomorrow on as well. Because there are 3 things that can happen in this case. This is the only case where this weird type of thing can happen. Right? In the first 2 cases I taught you today, it always goes exactly like I showed you. In the 2 cases we're going to learn when we do law of cosines, it's always going to go a certain way. This case, no. It could go one of 3 ways. When you go to solve this problem, it could end up being like the other 2 we've done, where basically you solve it and you get one answer. We only had one answer when we solved for A, and we only had one answer here when we solved for B. We only had one answer when we solved for gamma. One answer. Or, when we solve it, everything could end up having 2 answers. And when I say everything, I mean the stuff that wasn't given. The stuff that was given is done. You don't ever have to worry about that. Okay, but there are certain kinds of problems where when you're solving, you end up with double the answers for everything. Okay, so in this last problem, that would be like getting 2 answers for A, 2 answers for B, and 2 different answers for gamma. And that's not possible in this kind of problem. That could never happen. Right? But in this one, it could. And then the third thing that can happen is you start to solve the problem and you realize there are no solutions at all. The information that you were given makes it impossible. So let's go through. I'm going to pick one of these 3 cases to take a look at, and we'll see what happens. Okay, so again, side angle. That's the only case you have to worry about this ever happening. So, we already know that it's side angle because we had a diagram up here, and I asked you guys, and you said that it was side angle. So in this problem, you don't have any choices. If you like choices, you don't have choices. There are no choices about what you do. You have to find something first, then something else second, and then something else third. Does anyone have a guess at what you're going to find first in this problem? Yep.
Beta.
Yep, you're going to have to do beta first. The reason is because that bottom row is useless. You don't know the side and you don't know the angle. If you have a row where you're missing everything and you have no way of getting anything in that row right away, then forget about that row. It's not going to help. You might think, well, wait, couldn't I do Pythagorean theorem? Well, if you do Pythagorean theorem to get C, then you're already assuming this is 90 degrees. What if it's not 90? It might not come out to 90. So you can't do Pythagorean theorem to get C. And you can't add two angles together and get the third one because you don't have two angles. So the only thing you can do first is beta. Then, once you have beta, you'll have two angles. Then you can use those to get the third angle. That'll be step 2. And then once you have this angle, then you can finish by finding that side. All right, so let's set this up to find beta. Okay. Anyone think they can tell me what's going to go on the left side of my proportion? Yeah.
Never mind.
8.
Sine of 40 over 3.
Good. And technically you could have put that on the right. It doesn't matter. So sine 40 over 3. But we put that on the left, so now what's going to go on the right? Jess?
Sine beta over 2.
Sine beta over 2. Okay, look at that. That's different. We've never had a problem like that. What's different about that right-hand side? Tom?
You have the number at the bottom instead of the top.
Right, we've always had the variable. If you look back at the last two problems, the letter has always been in the bottom. This time the letter is in the top. That letter is inside of the sine function. Kind of like having something like this. Like having a number inside the square root function. Okay. So, we have to look at how we deal with that. Let's start the same way. Cross multiply. Okay. So you've got 3 sine beta equals 2 sine 40. That'll be online in a little bit. Okay. So 3 sine beta equals 2 sine 40. So far, so good. Now, my goal is to get beta by itself. Well, I can at least get rid of the 3 first. How would I move the 3 to the other side? Yep. Divide both sides by 3. Good. Okay. Now we have sine beta equals 2 sine 40 over 3. Now this next step is something we talked about last week. I'm taking the sine of beta. I don't want to do that. I just want to have beta. So how do I get rid of sine? You can't divide by sine because that's not multiplication here. That's a function. So we have to cancel it with another function. Yep?
We can take the inverse sine of both sides.
Exactly. You have to take the inverse sine of what's on the left and the inverse sine of what's on the right. Inverse sine and regular sine cancel each other out. And you get beta equals, and let me show you how you type all that in. Don't try to simplify any of it beforehand. Just type it in exactly the way you see it. Now, you're going to notice this is going to look different. Okay, all the other calculations we've done, they look the same. This problem is different because it uses inverse sine. So inverse sine, 2 sine 40. Close that for the sine of 40. Divide by 3, and then close that for the inverse sine. So everything there is in the inverse sine. The 2 sine 40 divided by 3. And that's how you type it on one of my calculators. And hit enter. So we get 25.374. This is not a no solution problem. How do I know that? I just got a solution. If this was a no solution problem, the calculator would have just said error. Okay. So we definitely have at least one answer. Let's write that down. 25.374. Notice where I wrote that answer in the box. I put it up a little bit higher. Just in case there's a second answer, I'm going to put it down below. I'm not saying there is one, but if there is one, I'll put it down below. So let me show you how to check for the second answer. And what you might want to do is just leave 3 or 4 lines because we have one step left in this problem. And then you can write this. But then we're going to fill in the rest of the work right up here. So to check if there's a second answer, take the angle you just solved for and subtract it from 180. If there's a second answer, that's what it would be. So let's take what we just solved for and subtract it from 180. I think it was 25.374. 180 minus 25.374. If there is a second answer, that's what it is. 154.626. Just going to write that off to the side so I don't forget it. Now, I have to check and see if that works. Okay, so I got that by subtracting the 25.374 from 180. That's always how you find the second answer. Now, see if it's possible to fit that angle and the one you were given in the triangle. So we want to see, is it possible to fit 154.626 and the angle that I was given to start? What was the angle that I was given to start this problem? Yep.
3 degrees.
How much?
40 degrees.
40 degrees. Can you fit a 40-degree angle and 154.626 in the same triangle? Don?
No,
No, why not?
because that would be more than 180.
That adds up to more than 180. So because the second answer came out as big as it did, it's too big to fit with the angle that was given. If it's too big to fit, we can cross it out. We don't have to worry about it. There is no second answer for this problem. Now let's say the second answer came out to 120. Then I would say, yes, it works. Because if you add it to what was given, that's only 160. You're still under the 180. So if you're under the 180, then the second answer works. And I think I go through that right here. So if there's another answer, it's 154.626, but we were given a 40-degree angle to start. So if you add 40 to what we think the other answer is, it's greater than 180. It's too big. The other answer is too big in this one. So because we didn't get a no solution and we didn't get a 2 solution, this is going to work out exactly the same as the kind of problems we've been doing. It's going to be a 1 solution. So let me scroll back up and then we'll just finish up the last 2 answers in this problem. Alright, so I got that. How am I going to get gamma? I already told you it's the second thing you have to do. But how can we get it? Oh, Johnny? How are we gonna get gamma? Think about, what do you know about all the angles in a triangle?
They're like 180.
They all do what to 180?
Or add
They all add up to 180, yeah. They can equal all kinds of different numbers, but they all have to add up to 180. So, what could we do here?
So would you just add the two?
Mm-hmm. And what does 40 plus 25 add up to?
75.
That would be 40 plus 35.
65.
65. So 65.374 is what those add up to. And what would I subtract that from?
180.
180. So 180 minus 65.374. Now I've got that last angle, 114.626. Now that we have a piece of information in that row, we can finish it off to find C. Okay, so let me just write down how you would find C. I'm going to go back to the row that was given. Sine of 40 over 3 equals sine of 114.626 over C. So what are we going to get? Let's see. 3 times sine 114.626. And we're going to divide by sine 40. Divided by sine 40. So for C, we get 4.243. Okay, that's going to round up. Sorry, it's kind of scrolling. And those are all my answers. So on the problems in the homework tonight, when you come across one that could be the no solution, 2 solution, 1 solution, keep in mind the one we did today, and they're probably going to be the same type. We'll talk about the no solution and the 2 solution tomorrow. Yeah.
Sorry, could you just go down to like the written part of the
Okay, I put the homework up on the right side. If you can't read it, I'll read it off to you. It's page 266, 9 through 13, 17 through 21, and 25. Those are all odds. 9 through 13, 17 through 21, and 25. All odds.